Ever wonder why places like Japan and California feel earthquakes way more often than, say, Brazil or Florida? It's not just bad luck. There's a real, super cool reason behind it. And it all comes down to what's happening deep, deep underground. If you like this video, please consider subscribing and hitting the like button. Tell us where you're watching from in the comments. Imagine the Earth's outside like a giant puzzle. These puzzle pieces, called tectonic plates, are always moving around, super slowly. Think of them like giant rafts floating on a river of hot, gooey rock. Sometimes these rafts bump into each other, or slide past each other, or even dive under one another. When this happens, it builds up a ton of pressure, like bending a ruler until it snaps. And when that pressure finally lets go, boom! Earthquake. So, places on the edges of these big puzzle pieces, like Japan sitting right where several plates meet, get shaken up a lot more. It's like being in the middle of a bumper car game versus just watching from the side. Pretty wild, right? Get ready to uncover the secrets of Earth's rumbling. Okay, so imagine a giant puzzle. The Earth's surface is like this puzzle, but the pieces aren't tiny. They're huge. These giant pieces are called tectonic plates. Think of them as massive rocky slabs floating on the Earth's hot, gooey middle part. These plates are always slowly moving around. It's like they're drifting on a super slow river. Some plates are really big, covering entire continents and oceans, like the Pacific Plate or the African Plate. Others are smaller. There are about 15 major plates in total, plus many smaller ones. Each plate is a solid chunk of the Earth's outer layer, the crust and upper part of the mantle. They fit together like puzzle pieces, but they don't always fit perfectly. Sometimes they bump, sometimes they slide, and sometimes they pull apart. This movement is super important. It's the main reason we have mountains, volcanoes, and, you guessed it, earthquakes. So, remember, the Earth's surface is broken into these big, moving puzzle pieces called tectonic plates. Imagine Earth is like a giant puzzle. The big pieces are those tectonic plates we talked about. Earthquakes happen mostly where these puzzle pieces meet. Think of the edges of the puzzle pieces. That's where all the action is. These edges aren't smooth. They're rough and jagged like bumpy roads. When the plates try to slide past each other, they get stuck. It's like trying to push two rough bricks together. They snag and resist. Pressure builds up and builds up at these stuck spots. Think of it like stretching a rubber band. You pull, and the tension gets stronger. Eventually, the rubber band snaps. With tectonic plates, when the pressure gets too much, the rocks break and the plates suddenly lurch past each other. That sudden movement is an earthquake. So, places located right on these plate boundaries, the edges of the puzzle pieces, are where you feel the strongest shaking. A famous example is the Ring of Fire around the Pacific Ocean. It's like a giant circle of earthquake hotspots because it follows the edges of several major plates. Imagine these giant puzzle pieces, the tectonic plates, bumping into each other. Most of the time, they slide past or pull apart slowly, but sometimes they get stuck. Think about pushing two blocks together. If they're smooth, they slide. But if they have rough edges, they can catch. That's what happens with tectonic plates. Their edges aren't smooth. They're jagged and bumpy. So, when they try to move past each other, like the Pacific Plate and the North American Plate along the San Andreas Fault in California, they can lock up. Even though they're stuck, the massive forces from deep inside the Earth keep trying to push or pull them. It's like stretching a rubber band tighter and tighter. This stretching or squeezing builds up a lot of energy. This stored energy is called stress or strain. The longer the plates are stuck and the harder the Earth pushes, the more energy gets stored. This is the pressure building up. It's like a ticking time bomb. When that pressure becomes too much for the rocks to hold, something big happens. The rocks break and the plates suddenly move. That sudden movement is what we feel as an earthquake. So, places where plates get stuck and build pressure are the spots most likely to shake. So imagine those big puzzle pieces, the tectonic plates, are pushing against each other. They're stuck, right? Like trying to push two rough bricks together. The pressure builds and builds. Think of it like stretching a rubber band really tight. You pull and pull. Eventually the rubber band snaps. That's kind of what happens with the Earth's crust. The rocks holding the plates together can't take the pressure anymore. They break. This breaking is called a fault. When the rocks break, the plates suddenly lurch past each other. They move. This sudden slip and movement sends out shaking waves. These waves travel through the earth, making the ground wiggle and wobble. That shaking is what we feel as an earthquake. The bigger the break and the bigger the sudden jump, the stronger the earthquake feels. It's like a giant, powerful snap deep underground. Sometimes this happens near a big city, like Los Angeles, which sits right near a major fault line called the San Andreas Fault. When that fault slips, the shaking can be really strong and cause a lot of damage. Other times it happens way out in the ocean, and we might not even feel it much on land. So, we know earthquakes happen where these giant puzzle pieces, the tectonic plates, meet. But why are some edges super shaky, like California, and others are chill, like the middle of North America? It's all about how these edges are shaped and how they move against each other. Think of it like sandpaper versus smooth glass. If the edges are jagged and rough, they get stuck a lot more. When they finally break free, bam! Big earthquake. This is what happens along the San Andreas Fault in California. Those plates are trying to slide past each other, but those rough edges lock up tight. On the other hand, some plate edges are smoother, or they pull apart instead of grinding sideways. When they pull apart, new stuff comes up from below, and it's usually a gentler process, like the Mid-Atlantic Ridge, where plates are separating. You still get earthquakes there, but they're often smaller, more like a little wiggle than a big shake. So, the roughness and the type of movement at the plate edge are the real reasons some spots are earthquake central and others are pretty quiet. Okay, so we talked about the edges of these giant puzzle pieces, right? The big cracks where the plates meet. That's where most big earthquakes happen. But guess what? Sometimes earthquakes happen right in the middle of a plate. Imagine you have a big cracker and you press on it. It might break in the middle, not just the edges. That's kind of what happens. The inside of the plates isn't perfectly solid. There are smaller cracks or faults hiding deep inside. Pressure from the edges can push on these inside cracks too. When the pressure gets too much, these smaller faults break, causing an earthquake. It's like the big puzzle pieces are getting stressed out and cracking from the inside. A good example is the New Madrid seismic zone in the central United States. It's far from any plate edge, but big earthquakes happened there in the past, caused by these hidden cracks. Another place is the North China Plain, which has experienced damaging earthquakes far from the plate boundaries. Okay, so we've talked about how plates snap, but sometimes one earthquake can actually make another one happen. It's kind of like knocking over the first domino in a line. When a big earthquake happens, it doesn't just shake things up where it started. That shaking sends waves of energy through the ground. These waves can push and pull on other faults nearby. Imagine squeezing a balloon. The pressure goes everywhere. Sometimes, this extra push or pull is just enough to make another fault, which was already under stress, finally snap. Think about the Hector Mine earthquake in California in 1999. That big one caused small shakers on other faults far away. Or after the 2011 Tohoku earthquake in Japan, scientists saw more small quakes on faults that hadn't moved much before. It's not always a giant quake causing another giant quake, but even small changes in stress from one can trigger a new tremor somewhere else. It's a complex chain reaction underground. Okay, so we know why earthquakes happen in certain spots, but can we tell when the really big one is coming? Like exactly when? Nah, not really. Scientists are super smart. They study everything about the earth, the rocks, how they move. They look at tiny shakes, changes in water levels, even how animals act. But none of that tells them, okay, Tuesday at 3 p.m., a big earthquake is hitting Los Angeles. It's more like they know certain areas are high risk, like places near those rough plate edges we talked about, or where faults are building up lots of pressure. Think of California. It's on a huge fault line, the San Andreas. Scientists know it's going to have big quakes eventually, but they can't put a date on it. Same with Japan, another spot where plates meet and grind. Knowing where is key. Knowing when is still a mystery, but knowing where lets us get ready. We can build buildings stronger, have emergency plans, and practice what to do. That's the best defense right now. All right, so we know earthquakes happen where the big pieces of Earth's crust meet or where there are cracks. But why do some spots get hit way more often than others? Think of Earth's surface like a giant, broken puzzle. These puzzle pieces are called tectonic plates. They're always moving, but super slow. Sometimes, when these plates bump into each other, slide past each other, or pull apart, the edges get stuck. Pressure builds up like stretching a rubber band. When the rubber band snaps, that's an earthquake. Places right on the edge of these big puzzle pieces, like Japan or California, are where most of the action happens. They're constantly feeling the friction and pressure from the plates grinding against each other. It's like being on the front lines of Earth's constant rearranging. Other places, deep in the middle of a plate, are usually much quieter. It's all about where you are on that giant moving puzzle. So we learned earthquakes happen because of big plates of rock moving underground. When they bump or slide, shake. Some places shake more because that's where the plates meet, or where the ground is cracked. We can't know exactly when a big shake will happen, but we know where it's more likely. Being ready is super important. Know what to do if the ground starts to wobble. Have a plan. Our Earth is always changing. It's powerful and amazing. Understanding why things happen helps us stay safe. Keep asking questions. Keep learning about our incredible planet. Thanks for watching. If you liked learning about earthquakes, give this video a thumbs up. Stay curious, stay safe, and keep exploring our amazing Earth.